Hey guys, welcome back. In this video, we'll talk about the channel estimation in 4G or 5G OFDM systems. Basically, we will see how to do the channel estimation across time domain or OFDM symbols. In the previous video, we have spoken about the channel estimation across frequency domain or subcarriers. So basically, we right now we have fixed, right now we have fixed least square estimator as the channel estimation solution, right, or technique. So I would like to take the OFDM grid. This is very important. In the y-axis, we have the subcarriers, and in the x-axis, we have the OFDM symbols. Right now, in one particular slot, we have symbols 1, 2, 3, and running up to 14. Right now, across the subcarriers, we had seen how to perform the channel estimation. Now, our goal is to see across the time domain. So, for this one particular slot, okay, we will get the configurations. We will means like L1 baseband would get the configurations from L2. Okay, so this configuration will be static for this particular slot. Whereas when we move to the next slot, we can get a different kind of configurations for which across the slots the configuration would become dynamic. So now, what kind of configurations we can get? One is in the previous video we are talking about a configuration type 1 DMRS, where the DMRS will be allocated across alternate RS, right? Then we will get a number of DMRS, or we can say pilots. So that for now let us take one, and we can say on which symbol we would get the we have to place this DMRS. Maybe for now we can take third symbol. This is the one, right? So with this configuration, we will get many other configurations, but right now these configurations are sufficient for us to discuss the required concept. Now, the thing is, across uh, across all the subcarriers in this third symbol, we had seen how to get the channel estimation, right? Now, basically, we need to see across time domain how to see the channel estimation, how to get the channel estimation. Now, since for this particular slot the configuration is constant, and for now we have only one DMRS, we need to definitely make a certain assumption that for this entire slot the channel estimation is, I mean, the channel estimates are constant. So basically, whatever you have estimated at H, I mean at the symbol number 3, you know, you have to use those. You have to use the same channel estimates across other symbols to decode the data, right? Why do we need this channel estimation? Like for example, you say here there is a data. Okay, I will say XD. So in this case, what is the equation? Y is equal to HXD plus N, right? Now you have to use the same channel to equalize the channel effects and get back this data. That is the intent, right? So this is one option we have. Okay, when we have only one symbol and we can go for certain kind of assumption. But let's say I will take the another OFDM grid. Okay, let's say this is some other slot and we get the configuration. Let's say I will say the number of DMRS symbols is equal to 2. So let's say third and 10th symbol I will get the DMRS. Now what happens? This is third and this is 10, right? So on across these two symbols we are going to get the DMRS, and based on the least squares we can get the chance estimation here. Let's say I will, for example, I will say H3 and H10. Now the thing is, so here we have multiple options. Okay, we can say that across this entire slot the channel is constant. Then how can you get to the better channel estimates? Anyway, we would be going for more number of DMRS symbol when the noise is more or the channel conditions are not good and we have a low SNR. Okay, in such case what we can do, we can say H effective can be, you just take the average of these two, right, and use this H effective across all the other symbols to decode the data, right, or to equalize the channel. So this is another option. Okay, But as we discussed in the previous video, the channel might not be constant across the entire slot, right? If we have the high speed scenario, then across each symbol itself the channel would vary. Now the thing is how to get the channel estimation. So here itself I will go for option number 3. Okay, that is, say for example I will divide this, you know I will divide this into equal of, which means if we have 14 symbols, uh, you know here we have seventh symbol, right? This is first symbol. Now for 1 to 7 symbols we can use 3 as the channel estimation, and uh, I mean for forming a channel estimation, and we can use this channel estimates across all the symbols to decode the data, right? Similarly, for 8 to 14 symbols, we can use the channel estimates from the 10th symbol, and we can decode the data. That is another option, right? So what about option number, you know, 4? So here you can see that the third symbol, right? The one, two, first and second symbol are close to third symbol. For this one we can use channel estimation H3. I will write here H3. Okay. Then for 11, 12, 13, 14, we can use, in all this area we can use H10 as the channel estimation. What about here in between? This is between H3 and H10, right? Here we can go for averaging, like this H effective. That is option 4. Okay, so as we saw that this H effective is is performing the averaging, right? This itself is one kind of interpolation, but definitely we can bring in a different kind of interpolation technique or different kind of interpolation scheme to produce a different kind of or better channel estimations across these symbols. Okay, so I will not go through the kind of the interpolation filters or interpolation schemes which we should use, but I'm giving an option that uh, you know you can go for different kind of interpolation schemes to get a better channel estimation. For that, definitely you have to perform some MATLAB simulations under high speed scenario or under the noisy environment, and you can see which is going to give the better performance. Okay, based on that you can decide the algorithm for your system, and if it works, and if such a kind of scheme has not been used by anyone else, then you can even apply for IPR patent. All right, what else options we have? Do we have any other option? Yeah, like sometimes um, you know we can go for, actually, in case of NR or 5G, we have option to go for even number of symbols is equal to 3, or number of symbols is equal to DMRS symbols is equal to 4. Okay, so under high speed case, especially in case of 5G NR, we are going for, we are planning to support up to high speed train, means bullet train, around 400 kilometer per hour, right? Otherwise, in case of 4G, maximum we can go up to 100 or 120 kilometer per hour, or even less than this. Okay, so under such high speed, there are expectations that the channel would vary frequently across the symbols, like the time varying channel. So we can go for more number of DMRS symbols to give the better channel estimations. So I hope you got the clarity on this, and how to perform the channel estimate across the time domain. So in the next video, we will see how to perform different other estimates which would help to perform the equalization. Okay, because for performing equalization we need the mainly the channel estimation H. So we got it. We will see to perform MMS equalization what else is required. Okay, so thank you very much. Have a great day. Bye bye. If you're looking for more videos, please do subscribe to the channel.